Okay, so I was talking to Gabo this morning, and he was asking me about a couple things. The first thing he asked me was, can we make it so that Claude can see, or AI can see in general, Fulcro inspect better, right? So it can actually see what Fulcro did the same way in the browser tools, you can see the Fulcro inspect tab. And I told him that that actually already existed. Somebody asking a question already? Or is that just a, oh, somebody's
They just
subscribing.
enable.
Okay. All right. So it turns out that I've already coded into Fulcro. First of all, it's clj-c, so you can run it from a regular closure REPL, which is convenient. And I also recently added uh, a REPL-based tooling that you can use to use the REPL to see either closure script or closure. It doesn't matter what you're doing. Um, to give you an API to looking at things like the transaction log that happened against right transact. So there was a load that sent this query, and it took it started here. Uh, it had this source key. It used this remote. And then if I go and look at the network log, that was the transaction. The network log says, oh, well, I ran a network query that's this, and the server gave me that, and that's how long it took. Right. So the things that you would normally look at in Fulcro inspect, and of course you already have app state. That's just trivial. Right. That'll give you the app database. Well, if you have the namespace imported. Uh, so you can always look at the database and then do whatever kind of right. That's the normalized database that I ended up with, and this is all right. It's a Fulcro full stack app, and I'm actually running it against the server, the server that could run in the REPL. There's a couple ways to hook that up. So I just kind of wanted to give everyone an overview of what this looks like and see if there's anything like new that you haven't seen yet. Give you some ideas of how we could leverage this with LLMs to help give them way better visibility into what's going on in the code they're writing against potentially, full stack application running from a REPL. So that's the overall objective of the lesson. So I'm going to kind of start from the top. This is a simple to do MVC app. Some of you have, or most of you have probably seen this. If I start this as a server on, I think that starts, what port does that start on? 8001. Hopefully it's the JavaScript is already built. Good, it is. So it looks like this. It loads a list from the server, which is pre-populated. But if you change things and reload, right, I just hit reload, it's obviously reloading it from the server, like the things persisted. If you go and look at Fulcro inspect, you would see like the network transactions happening as you check and uncheck things, and then reloading. Well, you don't end up seeing the load because inspect doesn't install before the load has happened. Uh, but you can clearly see that those items are coming in. You can look at them in the database. And so, when you're working on an app, uh, right, the whole philosophy of Fulcro is you don't really care what this looks like for the most part in terms of the data processing. In terms of the data processing, what you care about is the data. So you more care about this stuff. What's in my database? What transactions did I run abstractly? I checked a box. And what network traffic did that cause? And what was the response? And did I get success? How long did it take? Those are the things you should care about, not specifically what it looks like on the screen until you're tuning what the UI looks like on the screen. But right, that can just be a separate CSS sort of whatever task. So if I create some new item, I see the transaction. The transaction says I make a new item. That puts something in the database, right? I can go and look at the effects that had. Here was the transaction. We sent something on a remote. We added locally a temp ID with the temporary data, and then right, we have a before and after version of the database, so we can see how the database changed. And then on the network, we can see, oh, well, it sent add new item. It got a response. That's actually, it's missing the temp ID remap in the display here. I didn't realize that was happening. And then in the database, we'll see that the remapping happened from the temporary ID that was there to that UUID that came back on the network. I didn't realize my network tool wasn't showing you the temp ID's entry in the response. I should probably fix that. So that's your experience as a human developer, but Claude doesn't have access to Fulcro Inspect, the tool. It has to go and play with the REPL and play with the app here. It can get some of this. And in fact, it can get all of this if it follows the same procedure I'm about to show you. So you could do this in CLJS or CLJC. It's no difference to the Fulcro ecosystem. But with Claude and with tests, being able to run these things in Clojure without having to start up Chrome or Playwright or any of that mess, like being able to actually manipulate this application from a Clojure test in a full stack sense, where you could actually do end-to-end testing but never involve a browser and actually exercise all the logic all the way through the stack, was my general goal. And it just so happens that that works really well for LLMs, because what LLMs need to see is the data, and having to take screenshots of a browser or peruse the mess of HTML that React is generating without any easy chance of filtering creates a much higher context load for the LLM, makes it kind of lose its place more easily, and runs way slower, right? If it's having to do screen captures especially, right? If it starts doing screen captures then interpreting images, it's not going to be fast. And then of course, if you're trying to do testing, playwright testing is the same thing. It's doing screen captures, it's doing HTML analysis, it's trying to find elements and click on them in the browser. Your CI environment has to be able to spin up a browser. It's very heavy, very slow, very error prone, and is not something you can easily run very quickly from development. So I had always intended, from 10 years ago, I had always intended you be able to reason about everything in a Fulcro app from a clj-repl. Everything's been CLJC from the start, except for rendering. I mean, there is a CLJ rendering side as well, but I didn't expect you necessarily to want to use the REPL to see the UI. I expected you just to want to watch the data flow. So these pieces have always been there, right? Being able to kind of look at and do what you want via just a plain clj-repl. What was always possible, and I hadn't coded until recently, was what I'm about to show you. And I think I've shown some of you this before. And that's stuff that will make it easier for an LLM to work with this. So from my perspective, I'd rather use this tool, the Fulcro Inspect tool, if I'm developing a Fulcro app. Hot code reloads really fast. And so as I'm working on the UI, even though I don't necessarily care what the GUI looks like, this makes it very easy for me to peruse what's going on at the data level, or even the state chart level. We don't have any state charts in this app, which you all know, or most of you know. All of you who aren't new have been playing with this for quite a time. Okay, so let's ignore the Clojure script side of it now. And in fact, I'm just going to restart the REPL completely here and get something brand new. And I'm going to load this namespace. And instead of starting the server, going to take it a second. I don't know why it's taking so long. All right, that's just SLF for J dependency issues, which doesn't hurt anything. Okay, so what I've done in this namespace is I've pulled in, we already are using just an atom for the server-side database, so I don't really need to start and stop any resources for this app. Basically, all I have to do is start and stop the HTTP server, that's it. But I'm gonna not start the HTTP server. So this is the item database for items. Here's the mutation for doing a new thing, which just swaps on that atom and add something, checking and unchecking, right? They're just swapping on the server atom. So it's really easy to just, this was a quick to do MVC like demo that's in the Fulcro repository. And I thought this would just be a real fast thing to use to show you what I'm doing here. So everything you're sort of used to building at the lowest layers, mutations, resolvers, right? I've got PC def mutations here. These are the server side def mutations. The client side mutations are in the Fulcro to do MVC API namespace. So this API namespace here, these are the Fulcro mutations that run against the front end code. And then we're just matching them up with the back end code via PCSim, right? So when I see this symbol, I run this server-side mutation. So really straightforward. And then of course we've got some resolvers for being able to, pull a list from the server, pull an item from the server. All manual here, but all pretty trivial. And then we create a list of resolvers. We build a parser. Notice it's just a def because all this stuff is local. And then we build middleware. And then this is how we start a real HTTP server around it. Now, if you don't want to actually start the HTTP server, let's say you're doing testing or REPL manipulation, and the parser's enough, right? All the rest of this stuff is network encoding stuff. So I do have an integration that lets you use your Ring middleware as a remote on an app, but the easier thing to do is just use the parser directly. So you kind of skip the networking layers. So that gives you a little more speed. It does not give you any of the extra stuff that you might have put in the middleware. So depending on the kind of app you're testing, you might want to use the kind that uses middleware instead, or there's also a version that will let you actually talk it over localhost over the actual network. And so that's this build app thing. So here, instead of starting a server, I'm going to build a Fulcro test app with the same root that I'm using in the UI, which is written in clj-c, which has the, as you would expect, the dual DOM import. And then as a remote, I'm going to use a synchronous remote. So this basically makes it so that if you do a load or a mutation, it runs to completion through the quote network before allowing the application to return. So that makes it so that you can write tests that are just synchronous. You don't have to deal with asynchrony. Another benefit, right? In the ClojurScript testing side, if you were trying to do like a true full stack end-to-end test, first of all, you'd have to have some fixture that starts up the server separate from the ClojurScript. And then you'd have to deal with the fact that you're doing asynchronous things in ClojurScript and figure out how to like write the assertions so that they run after the interactions with the server. Real pain in the butt. This makes it trivial. And so a sync remote takes a parser, or takes a function that takes EQL. A parser takes an environment and EQL. So I just write a little adapter lambda here. That's it. So now I've built a Fulcro app that's going to run to do MVC UI against this local server-side parser. I'm installing some custom type handlers, and then this is the REPL tool. So the REPL tool installs on an app basically how Fulcro Inspect works is the Fulcro application, the Fulcro libraries, Fulcro, state charts, and UISM are all instrumented to emit events when you're in dev mode. In release mode, it just strips all that code out. But in dev mode, they'll emit events that, unless you have a tool installed, those events are just, sent off to the bit bucket. They don't go anywhere. But you can install any number of tools, and each one of the tools will receive the instrumented events inside of the Fulcro library ecosystem. And so that's what Inspect is showing you here in this UI. You register this as wanting to receive the application's instrumented events, and then it updates as it receives them. If that's not enabled in dev mode on the app, or you can actually enable it in production, which we do at Tatico. We have an alternate URL most of you know you can go to that loads the app with inspect instrumented in. Adds some overhead, but useful for debugging. So I made a REPL version of that. Basically what it does is it creates an atom that can record the events as they happen. So by installing it, we're basically saying, okay, now if I ask the REPL tool questions, it'll tell me what's happened. And then the start method is just a mimic of over here in here. I started to code it up for this demo to show you how you could share the start between the front end and the back end. The problem was, I don't remember what the problem was. Actually, I think it would just work, but I coded it here just as a quick and easy. I've already installed the tools. If you look at the headless namespace, it has an example at the top that just shows you, all right, here's basically how you could use this to run your full stack Clojure app that is meant to run in a browser via just your clj-repl. So you pull in these extra namespaces. The loopback remotes is where you can create a middleware or a network or a any kind of remote. This is the helper function that hooks up the rendering to capture the render frames instead of expecting them to go to a browser. That's basically what that does. It allows you to specify the root class, and then of course the remotes that you've hooked up more directly perhaps to your parser. And then you can just use the app. And you can use it by rendering the frame to hiccup. You could actually just look at the last frame itself. It's a data structure, if you like that data structure better. But if you like looking at hiccup a little better, you can render it to hiccup. And you can make assertions on it. You can run from the hiccup namespace things like click on a particular item. And that will actually run the quote client side, UI code that's hooked to that particular DOM element. And of course, that'll run a transaction. The transaction will cause the app to update. It'll render another frame. And then you can go and use your tooling that I was just showing you here to see what happened. So let's run through this. So build app is gonna build the test app and set it up so that it's ready. All right, so let's do that. So now I have an app, and then the start function is going to run a df load. So first, let's look at the tooling and look at the app's current state. Right, so I have no to-do list. Well, I have a list item 1 that's empty. Right, the network log is empty. The transaction log is empty. And so I'm going to say start app. That's going to run the load. That's the UUID of the transaction I submitted. And I can look at the transaction log and see, oh, all right, it ran an internal load mutation from data fetch that sent this query or wants to send this query to this remote. Then I can look, that's exactly what you see kind of with a little more detail on this tab. Right, not necessarily more detail, but because this doesn't show you the before and after state. I can look at the current state and I can see that, oh, all right, now I've got items that loaded from the server. I can look at the network log and see what the actual query was and what the tree was that I got back. And of course, then looking at the database shows me how that tree got normalized into the system. Now I can also ask for, I've already got this up here, I wrote this little last frame helper. If I use h last frame, let's do that just to show you the. Right, this guy gives you a tree of these internal DOM server element def types. I think they're def types. They might be def records, where it's sort of an AST of the DOM, right? So it has, the tag was footer, the attributes were this, the children were then these elements that were a span, and the span had a strong, and the strong had text when the text was 3, right, etc. Right? That's not very readable. I mean, it's an AST. You could write functions to manipulate it. That would be okay. But it's usually a little nicer if you take that data structure, and I made this hiccup namespace that takes that rendered frame and turns it into hiccup. And so if we say last frame, we'll get the actual, hiccup that you could use to render as HTML, right? You see the heading that says the list. You see the input that's for new items. And notice that on the key on key down and on change have the actual lambdas hooked to them that go with the application code. And so this is how you can manipulate the application. So let's talk about this for a minute. This is kind of noisy. It's still something a human wouldn't want to read, and I would submit that it's also more noisy than an AI would need. Right? An LLM trying to work on a particular UI with you doesn't necessarily need to see the header and the class names and all that mess, unless it's trying to fix the look of it. If it's trying to just see if it works and click on buttons and stuff, it would be much nicer to filter this down to the things of interest. Now, you could annotate this. Obviously, you might want to annotate this with like data tags or whatever. Like if I go to the UI namespace here and go to the root. Let's see, let's go find, let's say the to-do item.
Or an ID?
Huh?
No, I saw an ID on a button. I don't know if that's the thing that you're looking for.
Yeah, I was not remembering, but I was wondering if I had, if I was sending this in the computed props. I've got the ID, I've got the label. So like this is the checkbox. I could put like a, data. Oh, not that one. That's not where I'd want it. So this is the actual input, but it's kind of hard to find this input necessarily because I have to go and look and find where the label says, oh, well, this label is, this is the delete button, right? And this is the checkbox, and this is the label, which has the label string. And if I double click on it, it puts me in, so I could do things like, data item, and then I could use like string label. What can I do here? Something like that, right? So if I reload this particular guy and then go back to my server code, and I think I would have to tell it, this is some of the polish that would be nice. Like we should see now in the DOM, what needs to be done, toggle all, to-do list. Yeah, it should have been here. So I guess I don't remember how to force it to reload the UI. Might be that. Oh no, that just needs that sends force true for you. Let me think for a second what it's closing over. So like I said, a few rough edges. And I don't know why the UI itself, because it should be built. Oh, that worked that time. So I just realized maybe it closed over at root, so I had to reload the whole UI. Anyway, we could improve the hot reload, right? Being able to reload a namespace and have the UI update. That's a straightforward, just like tweak it. So then once you've got the hiccup, right, you can do things like, uh, find items by particular text. And then of course you can pull this on double click member there, which is just a Lambda that expects an event, and call it as a function. And so there are all sorts of helpers in this hiccup namespace, like click on some particular element. And so I don't think we have a double click yet. So that's, if you look at click, basically you hand it an element, it tries to find the on click, and then if that's a function, it runs on click with whatever event you passed or an empty map. It's pretty straightforward. So you can just write all the helper functions you need. So this combination of being able to find things could be used as the way to teach an LLM, oh, and here's what you should use to look at what you've got, so that you don't have to look at all of it, right? You don't have to blow your context window by continuously pulling, 1,000 lines of hiccup into your context window to just find the one little thing that you need to manipulate. Questions so far?
I have one with the REPL tool. The
Mm-hmm.
clear thing clears everything, or just the transaction log or the network log?
It clears everything.
Okay.
Except the
But we
database,
can make,
obviously.
yeah.
Yeah, but I mean, it's just an atom. So its event log thing is what it's messing with.
Yeah.
So you could make your own, thing that just filters out the things you want to clear. Because the event log's like all the events. So when you ask for like the transaction log, it walks the whole log and just gives you the transaction ones.
Got it.
Right. So I think if this has like a UISM log and a state chart log, right? So if you're running state charts, you can filter out just the transactions that were events being sent to a state chart, that sort of thing.
Yeah.
And I was showing, who was I showing the other day? Lucas, I guess. We already have into Tycho an integration of the state chart visualizer for server side, which would also work when you're loading CLJC client side stuff. That same visualizer could be used to visualize, but actually LLMs are pretty good at, if you show them the state chart code, they're pretty good about understanding them, as I think most of you had discovered.
Yep. Are you doing like this kind of tests on the Brazil expansion?
Not yet, but that's what Gabo wanted to start doing, is he wanted to start integrating this sort of thing in. And state charts are already by default synchronous in Clojure. And right, the sync remote allows you to do synchronous things. So you're basically your tests don't end up being a nightmare of, if you've ever tried to do Clojure test async against async,
Yeah.
Clojure script apps, it's really ugly.
Yeah, you're just guessing. Like,
Yeah.
oh, am I in the correct moment?
Yeah. And I mean, my general take is that you still should basically be unit testing all of your logic, right?
Mm-hmm.
Try to model it as a data modeled system where the primitives of Fulcro are just triggering those bits and flowing the data. That's all the primitives of Fulcro are doing, and keeping you from doing stupid distributed system mistakes, right? That's really all it's trying to do, so that you can unit test the vast majority of your logic without ever having to start a server. Your integration tests aren't necessary for the vast majority of your code. And then when you want to write smoke test like things, okay, well, let's make sure it is all connected in my unit. I haven't missed anything. This comes in handy for that. This comes in handy for, okay, now let's try making an invoice and putting a couple of items in it and auto completing products and et cetera, against a real live running infrastructure that happens to be running mostly in Docker on my local machine, right? That sort of thing. So it's just kind of the multiple layers of testing, but it turns out that the reason I designed it was that, right? I designed Fulcro to be CLJC so that you could be more REPL oriented, stay in closure, test your algorithms with CLJ, right? Work towards complete working data flow and data model before you ever begin to have to touch a UI. But then I do recognize that if you unit test everything, even if you do an excellent job of it, you very often, it's very hard to unit test some of the integration points, which is why we have limited integration tests and full smoke tests. And so this just happens to round out that story nicely and give you a way of doing those that doesn't involve writing playwright crap.
Mhm.
Okay, I feel like I've put everyone to sleep.
Hello?
Yep.
To me, this is so cool, and I'm not sleep. I'm having fun.
Okay, good. So
I
yeah,
was muted. Yeah, no,
this
that sounds good.
this hiccup
Yes.
namespace has a whole bunch of pre-written helpers, like, does an element exist at this, right, with this ID? Give me the classes, give me the children, give me the attributes of an element, where, find helps you find an element, find all the elements in the tree that match predicate, where it kind of traverses all of the elements in the entire hiccup and gives them to you one at a time, and your predicate returns true or false. And that one is leveraged to then give you find by class, find by ID, find by tag, right? This one's really handy uh, in a lot of applications where you can just give an element a particular ID, but you can also find things by text, look for inputs that are next to a label where you give it a label pattern, find the nth thing. So if, right, you got 6 things on the screen that are all have the same label, like a table where there's a button in each row that says delete, you can find the 3rd row and delete, that one, etc. And of course, because you've got these general purpose find with a predicate, and then once you have the element, like clicking on it or making anything that just extracts that lambda, because it's literally just a lambda, as you saw in the click implementation. Once you've found the element, you get the attribute that has the lambda on click, on double click, on change, whatever, and you just call it. So it's really easy to make, invoke handler is the generic version of that, where you can say what the handler key is. So I could have done double click. I could have said find the thing, colon, on double click, and then, right, like this, right, where the last thing is the event. Why is this a multi? Oh, right, because on change, things like on change take both an event. Do they just take an event? Yeah, they just take an event. But a lot of what am I thinking about? Uh, there are lambdas that we hang on the DOM for our purposes where it can take an event and then some extra stuff. So finding something on the DOM that's a lambda and being able to pass some arbitrary number of parameters to it makes this very generic. Okay, so Carlos, you started to say something or ask something?
No, especially.
Oh, okay. I thought, was it somebody else? Did I mishear who it was?
Well, I have a question, but it's kind of off topic.
Okay.
You say at the start of the meeting that we cannot connect the cloud for the Fulcro inspect, but I don't completely understand that. What is the barrier there?
Oh, what's the barrier? So Claude can access through the MCP. It can access the console. It can run JavaScript commands here. It can run ClojureScript commands on the ClojureScript REPL, and it can extract the HTML or take a screenshot of the screen. But it can't use custom plugins. So it can't jump to the Fulcro Inspect plugin and click on a tab and look here. Right? So,
Well,
but you could install the REPL tool in CLJS, and then it could use the REPL tool just like I'm using it at the Clojure REPL. It could use a ClojureScript REPL and do these exact things. I mean, not the hiccup stuff because you're rendered to the DOM then, but you could definitely use the REPL tool instead of, or in addition to, Fulcro Inspect. right? All this stuff is CLJC. It all runs in either side. And if you go look at this REPL tool install, it's literally just calling Fulcro register tool, which is exactly what inspect does. And register tool just takes a lambda that gets the app and then the description of what happened. And then the tool does whatever it wants to do with it. Inspect hooks it up to its UI, and the REPL tool just records it. Right? All this does is like swap into an atom, basically. Right? Records some times, tries to figure out what kind of thing it is. Like if it has ISM parameters, then it categorizes it that way. Otherwise, it categorizes as a transaction. It looks like this doesn't categorize. Oh, that's if the event type is an optimistic action type, right? And then if it's a send targeted type, it records as his network. Send finished it, records as his network. Send failed, records as his network. Yeah, so it just kind of looks at the events and tries to categorize them so that you can ask, hey, tell me the things that look like they were state chart events.
Yeah, it's not that simple like that.
Yeah. But it's really straightforward. The tooling, like I said, is built into the Fulcro library itself, the instrumentation. And I just give you a hook where you can hook into it and say, give me what's happening inside. And so this is how the Fulcro Inspect Chrome plugin works. This is how the Fulcro Inspect Electron app works for like mobile development, where you want to actually like see events coming from something that's inside of a phone, right? You can't, it's not a Chrome plugin, right? You need to open a WebSocket and the phone needs to be able to connect to the WebSocket that this makes to send it the events. The UI code here though is shared with the Chrome app. It's the same UI code. It's just here, it's an internal communication between the web page through a really complicated mechanism that Chrome defines. And here it's talking through WebSockets. But it's both are getting the exact same event stream, just from different connectivity kind of methods. And then now you've seen, you can also make a REPL one, and you can see it's kind of trivial to write. This is all LLM written code. That's why I'm a little like sounding a little rusty on it, because I mean, it may have some bugs in it, but it's basically what you need. And you know, yeah.
Ooh.
And that's also why when I was saying the this server here, this render with the code reload, I've not used it much yet this way, because I never like REPL development of seeing hiccup. I don't want to do that, right? That's not what I want to do with my eyeballs. But it's nice for tests, right? Where I can find the element I'm looking for, and then slash what was it? Send. Oh, it was invoke handler, right? So there's the handler I want to invoke, and I want to invoke on double click with, it doesn't matter what the thing is. And then I want to look at the last frame that rendered. And let's see now, what did I double click on? I double clicked on item 2. So if I go and look at item 2 should now be in edit mode, where you see, let's see now, item 3. Item 2 now has a value and it's an input, right? And it's got an on change and an on key down and an on blur. So the double click morphed it into the input, just like it does over here in if I double click, it morphs it into an input, and then I can type a new value. And then when I press enter, it goes out of input mode and switches back to just a display, right? A label with a checkbox. It turns back into a label. When I double click, it turns into an input. I thought it turned into an input. Hold on, what happened? Oh, I'm on the wrong one. Am I on the right one?
Still allowed.
Ah, there it is. No, there it's not.
Mm.
Oh, there we go. It's hard to see it in the DOM. There it is. There's the edit input that appeared. Oh, it just makes it visible. Actually, it's always there. When you double click, it changes the class here to editing, and that causes the CSS to hide the one that's just the label and show you the input field. So the thing that changes is this editing class, right? See? And then the CSS flips them back in and out. They're both actually there. There's the input field, and there's the checkbox, and there's the label. And in fact, so we could sort of cheat now that I remember that. If you come over here and look at the event listeners on that element, there's a change listener already installed. So we could edit it without it being visually editable, because we're playing at the REPL here, where we can actually see the lambdas to call, independent of the class name. Yeah. So yeah, see the inputs. The inputs are here. It's just whether or not the upper class says editing. So that's the basic idea. And of course, depending on what level of integration testing you're trying to do, you might want to, force authentication. Like for example, if we were doing this with the Tycho app, if you don't go through the authentication, then you haven't actually populated a session into the session store. And so any request that you were to send would fail because you're not authenticated. So creating some tooling around whichever application you're working on to make that part easy. Okay, I'm going to hook you up to the parser, but then I'm always going to auto inject the session stuff. Well, if you think about it, in most of our apps, we just use the parser directly. So when you install this remote and you have the parser here, right? You could put ring/request. You could put the stuff in here that you need to appear in the environment of the parser, and as long as you've seeded that data properly, it's going to think that just came from the session. So you are skipping some of the network layers, which still may be required because you might be requiring on the middleware, and that's where, like I said, you could rely on, like say the loopback remote that uses Ring middleware instead. And so that'll pretend, if you go and look at this guy takes the stuff you've sent, and there's an encode function and a decode function that default to print string or read string, which I think you'd have to modify to make that work with normal middleware. But this actually encodes it as a Ring request, calls the Ring handler with that request, and runs it through your, through your thing. This actually might work because what Fulcro sends is typically, right, it's a body that's already been transit encoded. And your middleware is going to transit decode it. So really all you have to do is get the body encoded as an input stream that the middleware will read. So this is the stuff that could be, touched up or customized to make it work with your particular middleware. And at that point, the only thing that you're not leveraging is like HTTP-kit, which we don't need to test HTTP-kit. Unless you were running a test that tested like upload size limiting, right? That HTTP-kit would reject, a 20 megabyte upload. If you're not caring about that, then there's no reason to to go any further than a ring remote. So that's gonna, right, that's gonna give you something you just plop here as your remote, and then it's pretty much going through the full stack. Okay, well, that's all I had. Any other questions?
Patch, Tony? Your patch?
What?
Like, can you send me the patch from Fulcro? Like this diff?
Oh, yeah. You just want me to send you what I did here to
Yeah,
make
the
this
diff.
work?
Yeah,
Sure.
yeah.
Sure.
Thank
I
you.
can do that.
Now you have to show us when you do this on the Brazil app.
Yes, I will. I will, guys. I will try my best to make it very, very, very easy to understand everything. Yeah, and I will.
Tony,
Yeah,
did you do anything like new to all this? Because I played around with this when we were doing our experiments and had pretty good success.
No, I haven't done anything new to it at all.
Okay.
This is
Nice.
all I did was very quickly convert some of the files in my to do MVC demo app to clj-c so that I could demonstrate it with that app.
I still have a repo somewhere on my computer that has all this thing working.
Yeah. So like I said, the main things that you'll find as you play with this is, there's a lot of generic, hiccup manipulation things, but there can always be more convenience functions. Like this click bubbling, right? It's like, okay, well, the thing I can find easily is this, but I want something that'll actually walk backwards up the tree like JavaScript would to hit the thing that I want to run, right? The on click that I want to run, that sort of thing. So that's a good example of a function that finds an element, right, gets a list of matches, and then, right, kind of plays with finding the first one that has on click in the right order, and then using, clicking on it. Okay.